When you eat some real fatty foods, like say some delicious French fries, they make their way through the stomach and into the small intestine. At this point, they aren't really French fries anymore, but since they're high in fat, they're still a little more difficult to absorb, and that's where your gallbladder comes in. This high-fat food stimulates the gallbladder to squeeze out some bile into the small intestine. That bile emulsifies the fat, or basically mixes it up, and makes it easier to absorb. This is pretty much your gallbladder's job: store and concentrate bile until the time comes to send it to the small intestine. It's not the most glamorous of jobs, but hey, gotta start somewhere. If we take a closer look at this magical substance, we'd get a rough breakdown that's something like the following: 70% bile salts and acids, 10% cholesterol, 5% phospholipids, 5% proteins, and 1% conjugated bilirubin. And the rest are small amounts of other things like water, electrolytes, and bicarbonate. Bile salts and acids are mostly a product of cholesterol metabolism, so an acid might look something like this, and its salt is the anionic form, something like this. These acids and their salts have both hydrophobic and hydrophilic sides, making them amphiphilic, which help them make cholesterol and fat in the gut more soluble in bile. The phospholipids are mostly lecithin, also amphiphilic, and also help make cholesterol and fats more soluble in bile. Now, gallstones are these round and solid stones you can find inside your gallbladder, and they're made from the components of bile, and so they're categorized depending on what they're made of. The most common ones are cholesterol stones, but there's also bilirubin stones, which are sometimes called pigmented stones. The first type, as you might guess, are made mostly of cholesterol that is precipitated out of the bile as a solid and formed these solid stones. These account for about 75 to 90% of cases of gallstones. This precipitation of cholesterol can happen in a couple of ways. First, the bile can become supersaturated with cholesterol, meaning that the bile has so much cholesterol that the bile salts and acids, or phospholipids, can't hold any more in solution. Because remember that these all help make cholesterol more soluble in bile. And so the cholesterol comes out of solution as a solid, or precipitates. Another, somewhat similar way is if you don't have enough of these bile acids or salts and phospholipids to help keep the cholesterol in solution. So the less you have, the less cholesterol can be in solution, and the more precipitates out. Gallbladder stasis, or inactivity, has also been linked to forming stones. If the bile just sits there, it can cause the cholesterol to separate and basically precipitate out as a solid. Kind of like when the oil in your peanut butter jar separates from the peanuts if it sits too long. Stones made of cholesterol can't be seen on X-ray, but rarely are the stones only cholesterol, and usually you'll see a bit of a mixed composition. If they have enough calcium carbonate, they might be able to be seen on X-ray. Remember that we said that there's a small amount of electrolytes and bicarbonate? Well, some of these electrolytes are calcium ions, and calcium ions tend to form insoluble precipitates with bicarbonate as calcium carbonate, which would be radio-opaque and visible on X-ray. But usually there's not enough calcium carbonate, and the cholesterol stones will be radiolucent on X-ray, and you won't be able to see them. Alright, so the other type of stone is a bilirubin or pigmented gallstone. These ones again are pretty self-explanatory, and are made mostly of bilirubin and therefore are pigmented. These are made when there's too much bilirubin in the bile, and it's combined with calcium to form the solid precipitate calcium bilirubinate. Since they're made partly of calcium, they'll usually be radio-opaque, meaning that you can see them on X-ray. Here's an example showing pigmented gallstones on an X-ray. Since it's the bilirubin in the bile, we'd maybe